Can you see the notes? If you don't mind, can anyone fill that? Yeah, okay, thanks. Okay, first of all, what are you know about the number system? So just you all pass through your all level ITs, I think so. So just tell me briefly about what are you know about the IT system? Please be interrupt. Don't be uh don't like this because it will get bored for you also. So keep calm and quiet, then you will get bored and after I think 30-35 minutes, you will do your own work. Just chat in the phones or just look your phones and do your own work. So please be somehow involved in this session. So these are just a friendly seminar. So okay, the number system is the computer is a artificial intelligence or programming something. Okay, that doesn't get the accurate knowledge like us because it is programmed like that. Okay, you have multiple languages and English, Tamil, Sinhala, or whatever. So in whatever languages whether if someone is speaking in that language or someone is telling in that language, you can easily understand, right? So for that, the computer doesn't have the language knowledges. It have programmed only using the physical or number system knowledge, but cannot identify all the numbers. Okay. It usually it's binary. Binary means one and zero. So whatever you type to computer, whatever you're going to build computer, has a main interrupt, which is transform your let's say you just talking to there's a multiple facilities nowadays. Okay, so while in a microphone, just you take you if someone has iPhone or whatever. Okay, so you can say, "Hey Siri," or just
Sir, can't hear your voice.
can you hear me now? Am I audible to you now?
Yes, now okay.
Okay. So let me take an example as an iPhone or someone or something. Okay, the Siri has a talkative mode. So when you open your phones or just saying some commands to Siri, okay, hey Siri, please switch on the go to the calculator, whatever. Okay, so how it is understanding your commands? There is some interpreter just got your voices and transform into binaries, which is 1 and 0, and send to the phone's AI to perform your commands. Likewise, the number system is working everywhere. Okay. Now, just going briefly to this part, this one of fuel of I think grade 12 section. Okay. In usually in the IT, we have four number systems. I think you all have a bit of knowledges, which is binary, octal, decimal, and hexadecimal. Okay. Uh, in this chapter, we are going forward through that. Okay. If anyone have doubt at the start of the session, I told you earlier, if you have any doubt or in somehow in a point, if you can't get the knowledge, please be interrupt via the chat or open up your mic and speak. Okay, you can take a pen and a note, whichever you want some points to write, you can write. In between, you are a little bit hungry or whatever, it's 7 is everyone's dinner time. So whenever you feel hungry, you just get a small snacks as for 2 hours and kept with you. And in between, you can eat. So I don't bother about that. But I need your 100% focus on this chapter. Okay. Okay, now go to the syllabus. Okay, number system, we have only 4 number system, right? Decimal, binary, octal, and hexadecimal. So decimal means the base is 10, which means we usually used 1 2 3 like that, and 1 to 9, which is base is 10, means whenever we get a base, we get up to base minus 1, which means if our base is 9 sorry 10, we have 1 to 9. If our base is 2, we have 0 and 1s. Okay, sorry, 1 to 9, no, 0 to 9. Okay, so the decimal is base is 10, which is start from 0 and 9. In between there have 10 numbers. So binary is base is 2, which is start from 0 and end with 1 in between two numbers. And the octal is base is 8, and the hexadecimal is base is 16. Okay. After that, we have most significant digit and least significant digit. Okay. Anyone tell me what is most significant digit? You can drop a chat. Okay. The most significant digit is the highest order bit in a binary number. Okay, the highest order bit in a binary number. Okay, I'll explain with use of. I'll explain with the whiteboard. Okay. Okay, can you all see this, right? Okay, let's we have a number like 1 0 0 1 0 1 1 0. At the very first time I told that everyone can see, right? Okay, at the very first time I told that the computer will understand our binary digits, which means zeros and ones. Okay, in here we have some binary numbers like 1 0 0 1 0 1 1 0, but it's all have some positions. Okay, it's all have positions: 0th position, first position, second position, third position, fourth position, fifth position, sixth position, seventh position. Okay, it have 7 position, means from 0 to 7. In which category you can identify as this number, which is a decimal, binary, octal, or hexadecimal? Just tell me with this binary number. It is according to decimal or binary, hexadecimal or octal? Mm, Shell didn't get any messages. Sorry. What is this? Decimal O, octal O, hexadecimal O, binary. Can't see. I think now you can all see, right? Connection error. Only you or other people can see this one? Okay. Yeah, binary cannot. Some people can see, some people cannot see. I think might be some may not. I don't. Okay. This is a octal number. This is base is 18 means we have 7 position. Okay. Okay. In the 7th position we have 1, right? Which means 0, 1, 2, 3, 4, 5, 6, 7. So whenever we count, we have to go from right to left. Okay, right to left. So right position we have start with 0, and the very left position, which means last left position, yeah, counting as our highest number. So it is 7th position. In here, this one is 7th position, and this one is 0th position, right? So in the 7th position have 1. We called that most significant bit. In the 0th position we have 0. We called that least significant bit. So this is for your understanding. Okay, now we go to our chapter. Now you all can see the notes, right? Okay. Might be some delay because of rain in some here. Okay. This for some knowledges. You already get this idea. The bit is zeros and ones, nibbles. This is not bother with our no, chapter. This is for your knowledges, and you can see this wherever in the atlas or some Virodhara books they printed in their website. So conversion. This is the major part in our number system. So whatever the number is, we have to convert from one position to another, which means the number has a decimal. We have to convert it to binary. If it is binary, we have convert into octal. So there is some simple method and some a long method also. Okay, we can convert a octal or hexadecimal number in a two ways. Okay, we can convert hexadecimal or octal, which means this is a big number, right? We can convert that. You can see this hexadecimal and the octal number. You can convert into two ways. One way is to just changes into decimal number, then binary, or the other way is you can directly change to octal to binary or hexadecimal to binary. So I think most of your school times they will teach like this: change the number into decimal, then change to binary. That is a perfect way like that. Yeah, that's a perfect way, but it is time consuming. Okay, so octal is 8 and hexadecimal is 16. Okay, the binary is 2. But somehow as a mathematical, 2 to the power 3, sorry, 2 to the power 3. Okay, 2 to the power 3 is 8. The same way, 2 to the power 4 is 16. So somehow have a connection with binary, octal, hexadecimal as base 2. Somehow have a connection. Okay, today we are going to see how the connection, how we changes using this connection. Okay, little bit one by one we will see. Okay, first we are converting our binary into decimal. Okay, binary decimal means base 10. Decimal is base 10. Okay, so whenever from whichever binary or hexadecimal or octal, whatever the number is, when we change to decimal, okay, got this idea? When we change to decimal, we should multiply by its base position. Okay, we should multiply by its base position. Okay, now don't think about that point after numbers. Okay, we go with small numbers. For example, I have 1 1 0 1. Okay, this is the number 1 1 0. First we get this idea and we go to this. Okay, what is this position? Zeroth position. This is first position. This is second position. This is third position. Okay, third position. We have a number like this. We have to change this into decimal. Okay, we have binary numbers. We have to change this number into decimal. So what is the base of the binary? 2, right? So we have to imply that in to the power and multiply with this value. So this is 0 position means 2 to the power 0 into 1 and plus 2 to the power 1 into 0. Likewise, this is 2 to the power 2 into 1 and this is 2 to the power 3 into 1. Okay, we have to add all those. We have to add all those. Can someone tell me what is the final answer? I think you may kept a note and pen with you, all right? So we can go with the go through that, and someone tell me what is the answer. This is 2 to the power 0 into 1 plus 2 to the power 1 into 0 plus 2 to the power 2 into 1 plus 2 to the power 3 into 1. I got two answers, two different answers. Mhm. Three different answers. Okay, I got three different answers. Okay, let's see which is correct. Okay, whenever we see a position of 2 to the power 0, whatever it is, 1 to the power, 2 to the power, 3 to the power, whatever the base is, the power 0 we consider as 1. Okay, whatever the base is, the power 0 we consider as 1. So this one is 1 into 1. Okay, after that 2 to the power 1 is 2. 2 into 0, 0. So we don't want to take this one. Okay, this is 2 to the power 2. 2 to the power 2 is 4. 4 into 1, 4. So now we add 4. Same way, sorry, this is 4, right? This is 4. And this is 2 to the power 3. 2 to the power 3 is 8. And 8 into 1 is 8. So the final answer is 13. The base of 1101 binary we have changed to 13. Decimal, the base is 10. We have to give the bases. Okay, whenever we change to one figure to another figure, we have to give its base. uh okay, now see with these equations. Okay, so when we point decimals, after the decimal, this is called after this called after the dot something. Okay, after a dot, the number we consider as minus to the power minus. Okay, after a dot, we consider the power as to the power minus. So in here it is start from 0 to, okay, left, right to left. When we are going to upwards, which means 0, 1, 2, 3, it is starts from like this way, left, right to left. But in a downwards, it is starts from left to right. Downwards means -1, -2, -3 to the power -4, like that. It is start from left to right. Do anyone have a doubt on this part? I just explained, after a dot, they have some minus powers. So the plus power, which means 0, 1, 2, 3, it starts from right to left, and the minus powers, -1, -2, -3, it starts from left to right. And nothing nothing to do more than the same way. Okay, we just the power only different. Okay, the power is only the different, but the way is same. We are starting from here. It is starting from 2 to the power 0, and it is 1, right? I think it has. And this is 2 to the power 0 into 1, and this is 2 to the power 1 into 1, and this is 2 to the power 2 into 1, and this is 2 to the power 3 into 1, and this is 2 to the power 4 into 0, and this is 2 to the power 5 into 1. As the same way, we are calculating this as 2 to the power minus 1 into 1. Okay, here have a minus 1 value, and this is 2 to the power minus 2 into 0, and this is 2 to the power minus 3 into 1. Okay. What is the 2 to the power minus value? If someone has think if minus value minus 1 means we just consider as 2 to the power 1 into 2, and we have minus 1 then minus 2. Someone think like that. If 2 to the power minus 2 means 2 to the power 2 is 4, for minus value we put minus in front of that, and it's 2 to the power minus 4. Does anyone thinks like that? Be frank. If it is yes, put a yes. So no one can see the chats, right? So I know that I can get the knowledge in position what in how understanding you all. What is the understanding of yours? Okay. Little bit annoying my classes because in the virtual we cannot see cannot teach a face to face, right? So somehow in some way you have to interrupt with me, then only I can got your feelings, or I can get your knowledges in which position you all have. Okay. In here the minus position, okay, the minus we are um, transferring like this, which means in earlier max you all study a little bit. Okay, okay, 1 to the power, sorry, 1 over 2, this is half, right? This is half, 1 over 2. Okay, it has the power 1. If there are any changes will happen, 2 to the power 1 means if there are any changes will happen, 1 to the power 1 over 2 to the power 1. If I put like a power 1, is there any changes happens? No, right? Yeah, there won't be any changes with this. Okay. Sorry. Sorry. This is 2 to the power 1. While we taking this is a dividing, right? 1 divided by 2. Okay. In the mathematics, if we have to take the 2 to the power something in the upside, okay, 2 to the power something in the upper side, it consists a minus in front of a power. We can say this, sorry, we can transfer this as 2 to the power minus 1. Okay, if someone have any doubt on this, 1 over 2 to the power 1 over 1 over 2 to the power 2, whatever it is, if we have to transfer like a 2 to the power only without 1 over, we can put a minus in front of the power. It's the same way 2 to the power minus 2, which is 1 over 4. 1 over 4. Because it's 1 over 2 to the power 2. Okay, a little bit I have a difficulty in writing this with the key mouse pad. Okay, if anyone have any doubt on this, please ask, because whatever we are studying today, you have to get 100% knowledge of this. No, sir, clear. Thank you. Okay, then this is 2 to the power minus 3 means 1 over 2 to the power 3, which means 1 over 8. So likewise, this is 2 to the power 0. I told you earlier, whichever the power 0, whatever the base is, the power 0 we consider as 1. Okay. Okay, from here onwards we go from right to left. 2 to the power minus 3 is 1 over 2 to the power 3, which is 1 over 8. 1 divided by 8. So 1 divided by 8 is 0.125. If you have a just okay, I'll give 2 minutes time. Okay, yeah, I'll give 2 minutes time. Go through with these questions and write your answer. It's 101111.102 to the base 2. Okay. From now onwards, you can start your works. It's 7:36. I'll stop you by 7:38 or 7:39. Okay, I got one answer and waiting for more. Okay, let's go. Uh, from here we start. Okay, it's third position from a point. Okay, third position from a point means 2 to the power minus 3. This is second position from a point, which means 2 to the power minus 2. This is after a point, which means 2 to the power minus 1. And this is first zeroth position. Okay, zeroth position 2 to the power 0, and first position 2 to the power 2, and second position 2 to the power 2, and third position 2 to the power 3, and this is fourth position 2 to the power 4, and fifth position 2 to the power. Okay, we all go with that. And this is 2 to the power 5 means 32 into 1, and 2 to the power 4 means 16 into 0. 2 to the power 3 is 8 into 1, and 2 to the power 2 is 2 into 1, and 2 to the power 1 is 2, right? 2 into 1. Oh, sorry, this is 2 to the power 2 into 1 means 4 into 1. 4 into 1. 2 to the power 0 into 1. Whichever the value 0, the power 0 is 1, right? So 1 into 1 is 1. Okay, here we have a plus mark. Okay, plus mark. It's not sorry, it's dot. Okay, so from here to here we have plus marks. So the dot, this dot, okay, focus on this dot will appear in here. Okay, this dot will appear on here. The same way in here also. Okay, answer this. 2 to the power minus 1 into 1. Minus 1 means I told 1 by 2, which means half. Half into 1 is 0.5. And
2 to the power minus 2, which means 1 by 4. 1 by 4 means 0.25 into 0 is 0, and 2 to the power minus 3, it is 0.125, which is, if we add all those numbers, we can get 47.625. But we are converting binary to decimal. So you can see in here, in the example, we have the base value. Okay, we have the base value. So after this, our final answer, we have to, not we have to, we should give, so we should give its base value as 10. Okay. This is another thing. We are converting octal to decimal. Okay. It is easy to converting whatever the number value or number system to decimal. We have to multiply it by its base value to the power. That's all. And the position, sorry, not the power, the position value. The base value and the position value. So octal means we have the base value of 8, and obviously we know the positions from, we are starting from 0, right? So our first position value is 0. So you all have a doubt why we are starting with zeros and why we cannot start with 1, like that. Okay, so I earlier told this is like this is a programming knowledge. So this is a programming languages. We are using this for programming languages to understand the computer. So in a computer uh, we have to call an array, ARRAY, array. So, okay, which is save all our data in its memory. So it is in the array list or in the array part, it is the storage starts from 0. Okay, while you on go with the chapters by chapters, you get all the ideas from my side. So yeah, in the array part, it is consist from 0. So that's the reason we are taking the binary system, or the number system starts from to the position of 0, right? Okay. So likewise, we are changing a octal number to decimal number. We have to multiply it by its base number and to the power position number. Okay, it's here 7. It will be multiplied by 8 to the power 0, and it is here 4, which means first position. It will be multiplied by 8 to the power 1, and here it's second position. Sorry, yeah, second position, and it's 2. It will be multiplied by, the 2 is multiplied by its base and the position value. If you have any doubt on this one, sorry, you have anyone have a doubt? Okay. Or if anyone have a question regarding this. If you all don't have a question, then I have a question for you. Okay. Let us one thing with the example of previous one. Okay. If we have a value like in here we have a dot, and we have a value of 4 and 3, we say, okay, 4 and 3, it is a dot, right? It's a point something like a previous one. Okay, in here I have a point, and the value is 4 and 3. After a point, it is 4 and 3. So what you all gonna do? If someone can just drop a message. then I can understand you all got the idea or not. At least anyone drop a message, or you can interrupt and you can speak. Don't think too much. It's the same way what we are doing earlier. In the earlier part, what we done after a dot position, yeah, it's the same way. Minus power. In here we are getting as 8 to the power minus 1 into 4, and this is 8 to the power minus 2 into 3. 8 to the power minus 1 means 1 over 8, and 8 to the power minus 2 means 1 over 64. Correct. Someone has texted. Yeah, you're correct. And this is hexadecimal. Hexadecimal means base is sorry 60. So for that, I just so okay. We go with the number system. Okay, we have 1. After that, 2, 3, 4, and 5, 6, 7, 8, 9, 10. So hexadecimal means we can go up to 15, right? Can go up to 15 because the number starts from 1, no, 10, 11, 12, 13, 14, 15. Okay, from 0 to 15, which is consist of 16 numbers. Okay, can anyone tell me what is A, B, C? Can anyone know? If anyone have a rough idea about that, it is A, B, why we using that one? Yeah, you're correct. But why we are using that one instead of using 10, 11, 12, 13? Sorry. Because you all can see usually we are using 10, 11, 12, 13 as a decimal numbers, right? For all number. So all number we computer can't even computer can't understand the 1, 2, 3. Also can only understand zeros and ones. Okay. So the actual reason is but somehow you are answering, you are trying to answer. Okay, it is a good way to learn. Trying to answer or trying to get the knowledge is a good way to learn. So keep it up. True. One is somehow you have got some idea about. Okay, let me explain. Because we are considering the 10, 11, 12 as a whole number. Okay, if something we can change a binary into this 10, 11 number with using our base point. What it? Let's see. Let's say for with an example. Okay. Mm, this is a binary number. 1010 is a binary number. Okay. And what is this base position? This is 0, 1, 2, and 3. So base value is 2. I am saying the position 0, 1, 2, and 3. So with the using with the using the base value and the position value, we can changes or convert into full binary number. So decimal value, which is this is consist of 0, 2 to the power 0 is 1, and 1 into 0 is 0. This is 2 to the power 1, 2, and 2 into 1 is 2, and this is 2 to the power 3 is 4, 4 into 0 is 0, and this is 2 to the power 3 is 8, and 8 into 1 is 8. If you add those values, we can get 10. Okay, this is the main reason we are did not using for hexadecimal such a number as 10, 11, 12, 13. Instead of that, we are using A, B, all are capital letters. B, C, E, E, and F. So in your questions, okay, just type. Okay, in your question, while you're seeing like A, B, C, you don't think it's too much. Okay, A means 10, B means 11. So we are multiplying it the number by its base and the position value. That's all. The main reason I told you, the main reason why I did not using like 10, 11 directly, because of we can change a binary number to a decimal number. So in that way also we can get the value of 10. So that's the way, that's the reason we are did not using the 10, 11, 12 directly to a hexadecimal number. I think you all got the idea, right? Okay. So this is an example of hexadecimal, converting hexadecimal into decimal. Okay, the position and the value we are multiplying and adding. Okay, if someone have a doubt on this part, you can get a note. You can write up note up to yours, because whatever I'm teaching, not a main thing. Whatever you understand in right in your own way, it is the key for your learning. So at the another time or tomorrow, day after tomorrow, what you're when you're seeing your note, you will understand what you wrote on that. You can't have a I don't have a memory power like that. So whatever I'm studying or whatever I'm listening today, I cannot remember today, tomorrow, or day after tomorrow. Okay, whatever I just wrote and kept, that only I can see, and whether I can get and understand. Oh, this thing I was studying. Like, okay. Do anyone have any questions? If no, we can move to other chapter. Chapter means other part. As soon as we complete this one, we can go with the gates chapter. Today I have planned only for 2 hours, but the seminar don't take time too much. And okay, I think if no one have any questions, so we can go through the converting whatever the number, decimal, binary, whatever the number, so decimal, octal, hexadecimal, whatever the number is, we're going to change to binary. Okay, it's simple. You all know division, right? From this part of division, I think you all studying from grade 3, 4, 5, 6. Put a box like this and dividing. Okay, so this is the way you are going to converting a number, whichever the number, decimal. It is I think use this method only for decimals. Okay, use these numbers only for decimals. I will give you can use this for octal, hexadecimal, whatever. But the best way for using octal, decimal, octadecimal in another way. I'll just go with that. I think I have added the notes here. Okay. In here, you will see like two numbers like 39.125. Okay, 39.125. But we don't divide the whole number, which means we don't divide 39.125 together and divided by 2 and get the answer. We don't do that. We only consider the whole value. After a point, I said, after a point, it is a somehow minus part, right? 2 to the power minus 2 to the power minus 2 to the power minus 3. Okay. So we have to consider only the value of 39 for the first. And we have divided it. And 39 divided by 2 means we can get 19 times. 19 times 2 is 38 and 1 is balance. The same way we have divided only, we don't, another thing. In here, we don't divide the remainder value or balance value. So the balance value or remainder value is our binary number. Okay. While we dividing the 19, we get 9 times and 1 is remainder. And when we divide the 9, we get 4 times, which is 8, and we get 1 as remainder. When we divide the 2 times, when we divided the 4, we get 2 times and remainder is 0. When we divide the 2, which is 1 time and remainder is 0. Okay, can someone tell me from which way we are going to write? From up bottom to top or top to bottom? It is bottom to top, right? Yeah. Whenever you're climbing a ladder, you always start with bottom part. It's like a ladder, right? You can see it's like a ladder, and we have to start with bottom part. It's 1 0 0 1 1 1. This is the binary value of 39. Okay. Then we have these three values 1 2 5. We have 1 2 5. Okay, how we gonna do that? In which way we are doing? We have in which way? What is the way to complete that thing? So how we calculate that 1 2 5? Mm-hmm. 0.125 means 250, right? Okay. Somehow, okay, somehow we have to get it as 1. Okay, somehow we are multiply and we have to get it as 1. Let's see. So first of all, okay, first of all, what is the remainder or whatever the balance is 0, right? 1 to 5. We don't have any reminder. Oh, before that, before the dot, we are 0 because we don't consider this one. Okay, before the dot, it is 0. So it is not considerable at the first time. Which is put as 0, but for our binary calculation, we don't consider that. But we should put a 0. And we have to get a whole value. which means 1 or something, we have to get it as a whole value, which is if you see this is a decimal, right? 0.125 is a decimal value, not this decimal. We're actually using as a decimal, right? Okay, this is a number system. We are using this as a option or value call. Okay, so first of all we have to base is 2, right? So binary is base is 2, and we have to multiply it by 2 at the very first, so it will get 250 since there is nothing adding in front. So we are putting a 0, and then we are trying to multiply it by 2 again. So 250 into 2 is 500. 500 means 500. Still we didn't get anything in front of a decimal or dot point. So let's give another time try. And 500 into 2, then we got 1 in front of that, and all the other values are 0. Okay, somehow we have 0.125. We have to get before the decimal value a value, and after decimal value as 0. For that we are multiplying by its base binary value 2. Somehow multiply, and we get at last 1, and in the end 0. So this is the binary value of 125 in here. Okay, just consider this. In here we are going to get the value from top to bottom. Okay, so before a dot or before a decimal, we are get the binary values from bottom to top. After a dot or decimal, we are getting a binary values from top to bottom. It is 0, 0, 1. So anyone have any doubts? Earlier also we just when we are seeing the position of the binary before a decimal or before a dot, we are took the position from right to left. After the dot, we are took the position from left to right. It's the same way this is. So then we do. Yeah, because why it is 1 means we are multiplying by 2. Okay, base value is 2. So base value is 2 means we can get only zeros and ones. If base value is different, then we can get a different value. It means a 4, 2, 3 somehow. But whatever your work is, you should your method. Okay, whatever the whatever the base value, your focus is you should make zeros after the decimals, and you get a value in front of a decimal. Okay, if something if the base is 4 and you have a different value, when you're multiplying with base 4, the number is will be different. Okay, somehow your idea and your process is you have to make all the values as 0 after the dot point. You have to get a somehow 1, 2, 3, whatever according to the base, you get the value in front of a dot. Do you got your answer for your question, or still it is confusing? Yeah, it is easier for me to teach uh, while in front of you all, because virtually I know virtually all studying or teaching little bit difficult, but the corona things all are change the system to virtually. Everyone are virtually connected. But I hope to conduct the classes with face to face. Let me discuss after the session as per your idea. So my idea is to conduct the session classes on face to face. So it is differ if you all can come then we can get the class on Saturdays, 5 to 7 or 6 to 8 or 9, somehow 2 and 2.5 hours time, because weekly once means we have to cover all the chapters. We all have 14 chapters to cover for all your A levels. Grade 12 have 7 chapters and 13 have 7 chapters. Okay, let me go with this. I don't want to confuse you all. Okay, I earlier said the binary, octal, and hexadecimal. Okay, binary, octal, and hexadecimal have a connection. Why? Binaries 2 to the power 1. Let's see. Let's say binary is 2 to the power 1. And octal is 2 to the power 3, right? And hexadecimal is 2 to the power 4. Okay. Okay. Okay, when you got a number with the binary value, okay, when you got a number, let's say the binary value we are taking as 100110001, like say, okay, common numbers 3, 8, okay, let's say this is 8 numbers. We have a binary number of 1001110 and 001. We have to change this binary number into octal and as well as hexadecimal. So, we are changing this into decimal by multiplying its base value and the position value, and after that we are dividing the whole value by the octal base 8. It is little bit taking time consuming, right? You surely have a question like this on your final examination of A level, so it will take a more time consuming. In the examination, we the time is precious. Not on the examination, every time the time is precious. Okay, for this, what is the solution? Okay, the solution we have converting this into is octal is power 3, right? 2 to the power 3. So from right to left, from right to left, we are separating numbers a set of 3. What we are going to do at a first, we are separating the numbers a set of 3, which means 1, 2, 3. Put a separation somehow, uh, separate, like this. Okay, we have separated this one, and after that 1, 2, 3, we are separating this one. So we have the numbers as 10 as a one box, and 1011 as another box, and 001 as another box. Okay, okay, now we are considering this with the binary base and its position. Binary base and its position. For this box, we are considering only for this box. Okay, we are considering only for this box. Next box, the one is consisting the position of 0, and this is first and this is second. Okay, if anyone have doubt on this one, or if anyone have confusion, if you don't have a confusion, then you didn't understand this point. I think you should have a confusion, then only you can clear this one. Okay, now we are taking this box. Okay, this box, and the position is for this 2, 1 is 2 to the power 0, and this for 2 to the power 1. It will be difficult. 2 to the power 1, and this is 2 to the power 2. Just write as a 2 to the power 2, 2 to the power 1, and 2 to the power 0. Okay. Okay. After this, we are considering this box the same way. This is 2 to the power 0, 0th position, and this is 2 to the power 1, and this is 2 to the power 2. Why we are going up to 2 to the power 2? Because 2 to the power 3 is our 8th position. So 2 to the power 3 is our octal number 8. And this is 2 to the power 0 and 2 to the power 1. Just transform like this and tell me the final answer. Just transform this and tell me the final answer quickly. Yeah. Here we are not adding the numbers. Okay. Here this is 1 and this is 3 and this is 2. We are not adding a 2 plus 3 plus 1, 6. We are not adding. Okay, we have separation. The number has 333, and we are considering like a box, right? Box, and we are fixing the value as well and add together. Add together means not plus. Is 2, after that 3 and 1. Altogether we are taking it as a 231. As the same way for 2 to the power 4 means power 4. So, okay, power 4, what we are doing? We are consisting 4 numbers from right to left as a one box, which means 1, 2, 3, 4. Separate, and 1, 2, 3, 4 as a separate. So after this separation, we are doing the same thing. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. For this part, 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Which means this box consists, like say, but 2 to the power 0 means 0, plus 2 to the power 1 means 2. Just take 2, okay? And 2 to the power 2 means 4. And 2 to the power 3 means 8. So this is 8. If we have a number like 1111, we get it is 8 plus 4 plus 2 plus 1, right? So when we are adding all those numbers, we get 15. So in the hexadecimal, what is the highest number is 15. Okay. So that's the main reason why we are separating the number as 4 for hexadecimal and 3 for octal. While you are adding octal 3 numbers, which is consisting 111, it is 4, 2, 1. If you're adding all those numbers, it will be appear as 7. Okay, if someone has to tell me the value for this hexadecimal. Easy, simple. 99. 8, and 1, 9. In here 9. And after that 8 and 1, here also 9. 9, 9, 99. That's all. This is the basic chart. You don't want to memorize all the, for this value I got 0, this value 1, this value 2. You don't have to memorize. You just want to know the positions number. This one is 1, 2, 4, 8, and this one is 1, 2, 4. If you know that number, you can just multiply that in your memory and just adding. If you nothing to multiply, you have only 1 and zeros, right? If it is 1, you can add a 2 or 3. Sorry, if the position's value 8, 4. If it is 0, you don't want to add. That's all. And this is another chart. So converting that binary to hexadecimal, and it will be the okay. Mm, yeah, decimal to octal, the same dividing. So they are we are normally dividing like put a box and dividing. So in here they are dividing the same, but without putting a box. Q means quotients means times. R for reminders. So when we dividing 67 at the first time, 8 into 8 are 64. So 8 times and remaining 3. And after that we have 8, and 8 times 8 is 1 and reminder 0. So like that you have divided these things. So this thing you all know, right? I just explained earlier, converting binary to octal with the use of the table. Okay, I was going through, I don't go much deeply. Computer coding system. This is a little bit uh, hard. This is a notes, okay, your A level notes, but I don't want to bother these things in your seminar session. So okay, I'll go with gates at the moment, right? So just wind up with the numbers and we just move with gates. Okay, what are you thinking about the gates? It's roller gate or iron gates? Okay, I'll give 3 minutes. Oh yeah, it's 8, 18, right? Okay, I'll give 5 minutes time. A little bit fresh up your minds with drinking water. If you are hungry, just get up your snacks or biscuits, whatever. Please come back at 8:23. We'll start with a new session of logic gates. Take some water and fresh up your minds. If you're hungry, get some snacks or biscuits. Okay, now we are starting with a new session, right? Okay, gate means not you are thinking like a roller gate or iron gate, or that's not okay. There's something in a electronic and electrical system. Okay, can you all see the screen, right? The notes, PDF notes. Yeah, thank you. And we are just starting with end gate. Okay, end means end. You and me, or I'm me and my somehow my brother. End means there will consist two numbers, right? End will consist of two numbers every time. Okay, which means while we are using end gates, we should have both numbers are same. We only using here as binary number, zeros and ones. So it should be two zeros or two ones. Both input numbers have to be same. Then only it will be works. Okay, like say if it's a logic gate, right? So logic only have true or false. In a logic, there are only two options: have true or false. So for true, we are saying it as one, and the false we are saying it as zeros. Okay, false we are saying it's zeros. For true, we are saying it's one. Okay, let's see with those. Okay, first of all, we have to know how to write these numbers, how to write, how to allocate like this. There is a particular order. Okay, let's me see first of all the order. The S1, S2 is the input. S1 and the S2 is input, and L we are saying like output. Okay, let's say two inputs. Input one and input. Okay, first of all, we will see with the how to we allocate the numbers with two inputs. Okay, when we have two inputs, when we have two inputs, for the first input, we will allocate two zeros at a time. Yeah, two zeros at a time, which means under the one a zero and another zero, and after that one and one. For the second input, we just shuffle that one, zero, and after that one, after that another zero, after that one. In here, I told zeros and ones are true and false value. Zeros and ones are true and false value. So for the two input, this is the way. First we give zero zeros, which means false false and true true. And for the second input, false true false true. Let me consider this with three inputs. Okay, consider with this three input. I just go with input one, input two, input three, like this. Okay. Okay. What we are gonna do for the first input? It's three input numbers, which means we have to consider as 2 to the power 3. Sorry. Then it have eight numbers or eight values or eight positions, like that. So for 8 position, for the first input value, we will give assign as zeros, 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 which means false, 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 then true, 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 like the same way. For the second input, we will assign false, false, then true, true, false, false, true, true. Like this is a theory, but you want to memorize all these things? Okay, when you are trying to do with 2 to 3 values, you can easily get the idea. For the third input, we just go with false, true. Always final input at the last input will appear like this, mixing of false, true, false, true, like that. Okay, false, true, false, true, false, true, false, and true. This is a basic method of allocating the digits or allocating the uh, na- what saying allocating the values for input numbers inputs. Okay, it's the same way. Uh, with the gate in here, for example, we got 2 inputs. Okay, for 2 inputs, we are allocating false, false, true, true, and false, true, false, true. For the end, I said 2 numbers should be the same, but it should be true. Okay, it should be true, because when 2 folds are multiplied together, you can get a true value. Doesn't consider as a mathematics. Okay, false means minus value, then minus into minus it is plus. Don't consider like that. Okay, logic means is a logical method. Okay, logically think something. 2 false can be multiplied together and become a true value. Can't, right? Always only two values only can multiply. And means multiplication. And means multiplication. So two true values will multiply and give a true value. Is there anyone have a confusion with this one? Okay. And the O gate, sorry, in the O gate means or have some choices. Sorry, this or that, like a choice. Okay, choice means sometimes if one is true, then okay, choice, like that, right? We have 2 choices. If something one is okay, then okay for me, but ota okay also okay for me, like that. Okay, so or consisting like that. We have 2 inputs, but at least one of those input is true, then our final value is true. So when the both inputs are false, then only it gets as false as decision or result. In the other parts, it always gets true values, because or means at least one of those true is enough for us. And here, last but not least, at the basic logics. Okay, the major part will go with not gay. They're not like a or say the last bencher students. Yeah, not will, sorry, the not gate will perform like that, like a last bencher student. The teacher says something and he will perform something according to completely opposite. Okay, the not is like that. Whatever you say, I'll give the result as completely opposite. Whatever you give as an input, I will give the output as complete opposite. If you give true value as an input, I will give as an output as a false value. That's my habit like that. The means the last bench students mindset like you think that. Okay, but these will deal all the two gates, which means end plus not. We have we can add the end gate and not gate together, and or gate and not gate together. With the combination of AND gate and NOT gate, we will get as NAND gate. NAND, N-A-N-D. And the combination of OR gate and NOT gate, we will get a NOR, N-O-R, NOR gate. It should be uh, consisting both of that qualification. And is a multiplication, so we have to give the input and get the not the result, not the results, output as multiplication, and we will get the output as the not gate input, and we will get the results. You will get a little bit confusion. Well, we'll go with the notes. I think you might be clear. Okay. This is the no gate, which means not and or. So or means we always adding, right? So we don't consider this at the moment. Don't consider this at the moment. Okay, let's go with this. What I am saying, what I said earlier, or gate, if at least one of those consisting true value is enough, right? At least one of those consisting true value is enough. But no gate is completely opposite for this. Whatever the value we are giving as a or false, true, true, true. This is the results, right? When we using the OR gate, this is the results. But when we using the NOT gate, see, the result is completely different. It is 0, 1, 1, 1, but using the NOR gate is 1, 0, 0, 0. Completely different. Same way, it will appear for the NAND gate. So, NAND gate, we have to first of all deal with AND gate. AND means both the one value should be appear as for the results of 1. So when we're seeing the AND gate, the result is 0, 0, 0, 1. But when we use the NOT gate with that AND gate, the complete results will different. Before earlier we got 0, 0, 1. I said the end NOT gate will appear like as a last bench student. Whatever you give the result, I give opposite to that. That's all. And opposite to 0, 0, 1 is 1, 1, 0. So 0 we are considering here as false, and 1 we are considering here as true value. And the XOR is completely different. Okay. The XOR are completely little bit different. Let's go with a briefly. Okay, don't go with much detail. Let's go with brief. So XOR like this. XOR like this. Two different input, then I'll be true. Okay. Two different scenarios or two different inputs you give, I'll give you as true as result. If same input either true or false, if same input you gave to me, I'll give as false as the result. That is the habit of a XOR gate. And XNOR gate is different, completely different, or completely turn around with XOR gate. Only two particular same input you give, I'll give as a true. Only if it is true or false, both input has should be the same. If there are any changes in the two inputs, I'll give as a false. That's my a bit like that. And now don't go with this one. Okay. We just go with some laws. Not a criminal law, civil law, not like that. This whole mathematical and logical laws. So we have a lot of laws: Boolean, idempotent, commutative, associative, inverse. Like we have a lot of laws. All should be we have to know, because without the knowing of these laws, we cannot go move with the logic gates. Okay. Or not, we can go with laws. I give some brief knowledge on little bit of laws, and at 11 10 8:50 we just discuss about the class times and the way, which means you are familiar. I think it most probably I'm much appreciating to the class while on physical, without going with these virtual classes. Okay, let's say discuss at the 8:50 or 8:45. Just let's be go with these laws. Okay, idempotent law. Okay, idempotent law means if we are multiplying or adding, okay, multiplying or adding the same inputs, same two inputs, okay, which is A, first input is A, then second input also A. If you are adding or multiplying, if you are adding or multiplying, the result should be the same. If we are adding or multiplying the two same inputs, we will get the results is the same. That is the idempotent law. Okay. You know the truth table. We will study the truth table, all things in the our class chapter. We will when we go with the chapter wise. Okay. Okay. Identity law means sorry. Identity law means whatever you are doing with that input. Okay, we have only two inputs and we are deal with two inputs. Okay, and one input's effort will not uh, change the other input, which means we are taking A and B. Say for an example, if you are adding A and B, what is our answer? It should be A plus B. If you are multiplying A and B, the answer should be A into B, like that. But when we are adding A plus 0, our answer should be A. Or when we are adding one, sorry, when we are multiplying 1 into a, our answer should be a. So one's input does not affect the other input. In the results, we are getting the input as the same output. So while I'm saying this on virtual, you will get a little bit hard to get the idea. But in a virtual, in a okay, students will prefer. Okay, then I'll discuss with you because online teaching is a little bit difficult for students. That's what. Okay, fine. Then we'll conduct the class sessions on online and let we discuss the time. Okay, think only one student here. So I think let's we wind up and Mr. Rimas, you will discuss the time with the students if it is familiar for them. 5 to 7 or 7 to I think 6:30 to 8:30 is okay because getting delay they also feeling little bit tired. Okay, let's wind up the session with only one student remaining. Okay, thank you for joining. If you have any questions regarding today's session, you can ask. Okay, that's good. And have a good day. Thank you.